So partial negative, it looks like Mickey Mouse ears or something like that. So they have a partial negative and a partial positive on either side of it. So this can happen, and that's the polar molecules. Okay, so when this happens, the positively charged hydrogen side of one water molecule is attracted to the negatively charged oxygen side of another water molecule. This force of attraction is called a hydrogen bond. So remember, the positive and the negative are always attracted to each other. So sorry it took me a little time to get there, but we're there. All right, so you say you've got a whole bunch of these water molecules that are floating around like this, and they have positively and negatively charged. Oh, this one's negatively. Ions on them. And so when this happens, the positive and the negative are attracted to each other and will connect, and it's called a hydrogen bond. Okay? They're bonds that form between molecules, not between atoms. So they're not between individual atoms. They're between molecules, which are atoms that have of different types that have joined together. All right, solubility. Solubility, like water, for instance, is the ability to dissolve many substances, or solubility is what water does, which is dissolve substances within it. I learned from when I was reading this that water is called the universal solvent. It's because the majority of compounds in creation are either polar or ionic, and water readily, easily dissolves polar and ionic substances within it because it is what is the word? It has a polarity already within it, and so that polarity of the water, it took me a while to get when I read it, breaks apart the molecules of the substances that come within it, and so the negative pulls on the on the positive, and the positive charge in the water pulls on the negative of the thing that's within it. And like when you're stirring sugar or salt within your water, why does it dissolve? It's because of the charge within the water that's so polarized that it helps pull apart. And it only works if it's a substance, which most of them are in the world, either also polar like water or ionic, and we already know that means they give or take the electrons readily. So what is something that is not polar or ionic? Well, something that has no electrical charge in it. A non-polar molecule like olive oil, canola oil. You mix them with water, they don't mix because they're not polar or ionic. All right, moving on. Hydrogen bonding and the phases of water. So hydrogen bonding keeps the water molecules close together and limits their movement somewhat. As a result, water is a liquid at room temperature when other chemically similar substances are gases. It has a long, beautiful paragraph about how that's so critical and important, as there would be no life sustained on Earth if it wasn't a liquid at room temperature. One thing that I think is important is water molecules are closer together when water is a liquid compared to when it's a solid. Think about when you freeze something, like I'm going to go make some applesauce, and then I'm going to go put it in the freezer in a jar, a glass jar. Do I fill up that glass jar all the way? No, because what's going to happen? It's going to bust and break open the glass when it gets frozen, right? So I can't do that because when the water with the molecules that are within the applesauce freeze, they pull apart, and it gets bigger. So think about your ice cube. I don't know if anybody has ice cube trays anymore, but we do. And they grow. It's like magic. You don't fill up your water cube trays all the way, and yet somehow they're full and all connected at the top when they freeze. So because of that space that's created between the molecules when it expands like that, it is actually able to float on top of water. So ice will float in water because of that space that happens. It's the same number of molecules, they just spread out, right? So then it floats, and it's really cool because if ice didn't float on top of, say, lakes, all the fishies would die, and all sorts of ecosystems wouldn't be able to survive when it got really cold. So God thought of everything. All right. Because of hydrogen bonds and polar water molecules, it takes a lot of heat to increase the temperature of water. So it has a really high boiling point. So we're talking now going the other way with water. So instead of into a solid ice cube, we're trying to go into the air and evaporate. And so now that's also because of the hydrogen bonds, and they go explain it really beautifully here. And this is getting really long, but I will tell you anyways. Hydrogen bonds and polar water molecules make it so that more energy is needed to break the bonds before the molecules can move apart. So it takes higher temperatures. Like sand, for instance, heats up a lot faster than water. And in fact, the capacity of water for heat is 5 times greater than that of sand. That's why it burns your feet so quickly, because the sand absorbs the sun's energy 5 times faster and gets much hotter than the water that's near it. Just a bummer if you want warm water and you're in Oregon, but that's okay. We're gonna be thankful for just having an ocean nearby. All right, water, lots of little water things, and we're done. All right, hold on, we're almost done. This is a big chapter, but we got this, and this book is gonna stay open. All right, cohesion adhesion. All right, cohesion is the force of attraction between molecules of the same substance. So they want to stick together, and they are the same substance. So it's like water molecules wanting to stick to more other water molecules and flow together. Cohesion, like cohesive. We have a cohesive group. That means we are all the same type and we are stuck together. We like each other. We have a good connectivity. That's what that usually means. All right, adhesion. If you adhere something, you're adhering one thing to another thing. The same type of connection, only between 2 different things. So cohesion, same. Adhesion, different things, okay? And now I have 2 really cool actions that happen with that. One of them is called capillary action. In England, we say capillary action, but capillary action is this really cool phenomena that happens, say, when you spill milk on the floor and you take a paper towel and it just creeps up the towel. It's using the cohesive nature of the water sticking to itself. It's using the adhesion of it wanting to stick to the water, wanting to stick to the paper towel, and the spaces that are in the paper towel as part of the pool there. This also happens in a tiny little tube, if you had a teeny tiny little glass tube and you put it in water, it would just miraculously, the water would just go up that tube. It's called a capillary action. But it also happens in plants when you put food coloring in water and stick a celery stalk in it, and it just creeps up it. It also happens in our bodies, in our capillaries. All right. And then we have surface tension. Ooh, I almost missed meniscus. Meniscus first. Meniscus is when you have you pour some water into a glass, and you can see when you look from the side that there's a little bit of a concave shape to it. That is called the meniscus. And it does that because of it's more strongly attracted to the glass on the sides, the water is, than itself. There's a stronger attraction in the ions and the atoms, okay? And so the molecules, I guess it would be in water situation. So they're drawn to the charge in the glass, which does have a charge. It's not neutral. In fact, I think I read that that plastic is more neutral and it won't have as much of a meniscus in that. If it is as other substance, so I'm trying to remember what it was called, that mercury. Mercury is more attracted to itself, and so it will have a convex meniscus. Last point, surface tension. All of these molecules have all sorts of charges going on and attractions going on between them, and say like water, and they get really strong on the outermost side, as you can imagine, that like any kind of the outside of an atom is the strongest anyways too, and so very similar, and that creates a surface tension that you can literally take a glass of water and drop something that's not too heavy, like a hair or something like that, on top of it, even a leaf maybe, and it'll just sit there. And we did an experiment on that in class, and the paper towel and I think paper clip even also just sat there on top of it for quite a while until it just filled up with water and got too heavy and fell down. So it's surface tension. And so I think that has covered everything in the eternal module 4. We did it. Good job, everybody, and have a wonderful, wonderful week.